and record. Go.
Okay, today what we're going to look at is Pythagoras but in 3D. Now I know some of my most adept scholars in the theory of Pythagoras in 2D often have difficulty when they have to transfer their skills and put it into a 3D shape. Okay, here we've got a cuboid and we're going to be working out various lengths of diagonals and sides on this cuboid using the 3D Pythagoras method. So if we go over to the first board and let's have a little look at our first side we're going to work at, and we're going to be focusing on BG, which is, zooming just back here, which is this diagonal here. Now what I'm going to do quickly is I'm just going to draw it with a dotted line on the cuboid itself, on the 3D model. Now the art of working out the 3D Pythagoras is to actually translate your shape into a 2D shape. So if I'm working out BG, I've got B and G there obviously, and then we've got C, because C is the third letter that makes a triangle up. So using Pythagoras now, a right angle is formed because it's the face of the cuboid. We're trying to find the hypotenuse, so we're going to add. So first of all, we could say BG squared is equal to CG squared plus BC squared. Using our Pythagoras, CG is 3 squared plus 2 squared. So that gives us 9 plus 4, which gives us 13. To find the BG itself, we've got to find the square root of 13, which I'm going to go over here and get a calculator. Which square root of 13 is 3.6. So 3.6 will give us BG. Now that's known as a direct calculation, and that's one they normally give you on an exam paper or something just to warm you up. Now this is where it gets difficult. The second part of the question will normally ask us to find a side or a length which is not related to the side itself. So we've got to break it up into two stages. We're actually asked to find AG. Now AG is this diagonal here which joins the far corner right over to the top corner there. So it actually cuts right across the shape. We can't find that out directly, so what we've got to do is do it in stages. First of all, we're going to consider the triangle, the base of this cuboid, a triangle ABC. And what I'm going to do, I'm going to quite nasty draw a line linking A and C together. Alright, I've got a bit of a wiggle in it. How's that? I haven't got my ruler with me. You'd be using a ruler if you did this. So, A to C, we're going to join that line up there. Now the reason being, that will then give us the base of the triangle at a later date. So we can go on and work out AG. So let's go back to our 2D over there, and let's go and work out this AC line first of all. So using our Pythagoras, we're going to have AC, again it's the longest side, the hypotenuse that we add. So AC squared is going to be AB squared plus BC squared, and that gives us 6 squared plus 2 squared, and that's 36 plus 4 gives us 40. So AC is going to be the square root of 40. So the square root of 40 comes out to be 6.3. Okay, so now we've got our length of AC, which is 6.3. So let's put that in greens. We just found that out as an extra because we didn't know it. So 6.3 centimetres is the length of AC. Now, we've got AC, which is our bottom diagonal. Let's go back to this diagram here. AC is our bottom diagonal. Now, we want to try and work out AG. So I'm going to draw the diagonal from A to C. So this is a triangle that we're actually interested in. We've worked out this AC as being our 6.3 centimetres. Our CG we know is 3 centimetres because we're given. So let's translate this 3D triangle onto a 2D plan over here. Here's our 2D plan. So all we've got to do now to find AG is to do Pythagoras on this triangle. Remembering this must be a right angle because AC forms the flat base of the cuboid and CG is a vertical. So that is why that must be a right angle. Okay, so we're going to have AG squared is going to be equal to CG squared plus AC squared. That gives us 3 squared plus 40. Now I can write 40 straight away because I remember that AC squared was 40 from the previous question. I only got that 6.3 when I square rooted it. That's a common shortcut that you can use. So I'm going to have 3 squared there, which is 9, and 40 gives me 49. So no calculator needed for that. The square root of 49, which is going to be AG, comes out to be 7 centimetres. Okay, that is an introduction into 3D Pythagoras.